If one Mars exploration rover can find this life, then why have two been sent to Mars?
The world history tells us that exploring Mars, we have less than 50% success rate. So to increase the probability of success, we sent two. We're sending them to two different sites. And if everything works perfectly and as planned, we will get the highest scientific return ever from two rovers on the surface of a planet.
Orlando Figueroa is NASA's director for Mars exploration.
The rovers will go to two sites in Mars, searching for evidence of persistent water activity. That is, places where perhaps in the past, or maybe even in the present, water was present for a long period of time. That's important because that would be essential for life to take hold in the planet if it ever did. So we're looking for any evidence whatsoever we can find on minerals or evidence on the soils that tells us whether water was there.
However, these are not the first rovers to explore Mars. In 1997, the Sojourner Pathfinder rover transmitted unparalleled science data from the Martian surface. So how do these two new rovers compare?
Well, they are significantly more capable. I mean, they are, you compare the two, Sojourner was 25 pounds, and these are 400-pound rovers, equipped with a totally different kind of instrumentation, scientific instruments that are unprecedented in the surface of Mars.
Everything is entirely different. Whereas Sojourner was a fairly small machine, about the size of a microwave oven, these rovers are much, much larger, about a factor of 8 larger, about a factor of 10 times heavier. And they're going to be driving around the surface for a lot longer. They'll go a longer distance, they'll survive a lot longer, and do a lot more real science.
With a less than 50% success rate, exploring Mars is a risky business.
Entering the atmosphere or even orbiting a planet is extremely hard. Now, I think we have done as much as we possibly can do, as much as humanly possible, to increase the probabilities of success. The careful selection of parts, extensive test program. So we have done a lot. You know, there is still a chance that something could go wrong. We hope it doesn't. And we have a lot of people watching very careful at everything that's going on to minimize the probability of that happening. It is always very hard.
One example of recent failure is the lost contact with the Mars Polar Lander in 1999.
Mars Polar Lander was basically the first time ever that a lander was going to the South Pole of Mars. We're extremely excited about it because basically it was a robotic climatologist and geologist.
Karen McBride is a program executive in the Mars Exploration Program. She helped implement the suite of instruments to be used on the Mars Polar Lander.
So basically what would happen is the spacecraft descended, you would be taking pictures of Mars, and then as it landed, the camera would scan around, and then it would also pick its place where they wanted to actually dig. We had a robotic arm that at the end of the robotic arm was a robotic arm camera. And when you would dig in the soil, we were hoping up to at least a meter, you could look at the different layers. And at the same time, we had a meteorology package on it also, which would give us daily weather. And so that all together, we were very excited. And overall, it was a fantastic time, but I wish that the outcome had been different.
However, despite the mission's failure, Karen McBride has reason to be optimistic that the recently greenlit scout mission Phoenix will conduct all of the original experiments of the Mars Polar Lander.
Phoenix is a Mars Polar Lander Plus. It is now going to the North Pole of Mars, but it has enhanced instruments from Mars Polar Lander as well as a few new instruments. If everything goes well, it will launch in August of 2007 and land in May of 2008.
Currently, there are 2 orbiters studying the Red Planet, and the Mars Odyssey is one of them.
Mars Odyssey, its job is to map the elemental composition and also the minerals on the surface, follow the water, and also measure the radiation environment.
Michael Meyer is NASA's senior scientist in astrobiology. He is also the 2001 Mars Odyssey program scientist. The Mars Odyssey has now begun coordinating its science data with the MEO rovers on the Martian surface.
more effort will be spent on characterizing the immediate landing site. And that way you have information from the ground and also information from orbit, and you can put those together and basically cross-calibrate your instruments and also put things in a much better context. The Spirit and Opportunity may tell us something that we didn't expect about the planet and might move the scientists into looking at something else in particular that we could obtain from Mars Odyssey.
However, unlike the exploratory rovers, the Mars Odyssey will be active for a good deal longer.
Mars Odyssey, the prime mission lasts until August of '04, and that's basically a little bit more than one Mars year. And we did very well in the launch, the maneuvers while in transit to Mars, and also in aerobraking, getting into an orbit around Mars. That there's much more fuel than we had anticipated, and in fact we've been able to do things in orbit itself that have saved fuel. And with that, we expect the orbiter to last over 10 years.
So it would seem that with the Odyssey active for another decade and the Phoenix Scout mission due to be launched, Mars exploration has a bright future. But what of human exploration of the Red Planet?
This is the kind of foundation observations that we would need, not only to, in essence, build the case for human exploration beyond just exploration itself, and also to help us understand what the planet looks like, what it is, what it's made out of. You know, certainly before we send any humans, we would need to know that.
But perhaps one day in the not-so-distant future, man will set foot on the surface of Mars. As for humanity one day calling Mars a second home, that could be slightly more challenging.
Mars, although our neighbor, and let's say the closest place to Earth in terms of how it is, it's still a far cry from what we would call habitable. Although the noontime temperature around the equator on Mars may get up to above freezing, it's only a thin little, near the very surface of the ground that it gets that warm. The air is still absolutely freezing. The average temperature of the planet is something like minus 87 degrees Fahrenheit. Its atmosphere is mostly carbon dioxide.
If we are to one day arrive at Mars, with a view towards future human colonization, with such harsh and inhospitable conditions, it would be impossible to survive without the use of artificial life support systems, such as enclosed environments, producing oxygen and wearing pressure suits. But what if Mars could be modified to act as our life support?
If we hope to live on Mars for any extended period of time, obviously the first way you do it is you build habitats under pressure. It wouldn't be that different from, let's say, living on the top of Mount Everest or under the ocean, that sort of thing, where essentially you have to build your own environment. But for long-term colonization of Mars, you might want to consider terraforming the planet.
Terraforming, a process whereby a lifeless world is engineered to become an Earth-like biosphere.
You're left with the fundamental problem that if you're going to have humans living on another planet other than this one, you're going to have to either keep them in a box where you're controlling the environment and everything, or you actually have to change the planet that they're on so that it's habitable. And for that, it's a pretty long-range process, of which right now we don't really know exactly how to do it. We have some ideas, but it certainly is a hundreds of years process of how to bring Mars to higher pressure, make water stable on the surface, to put oxygen in the atmosphere so it's breathable. It could be tough.